All right, guys, so let's get started. Okay, so again, to keep the topic on Tuesday, all right, we're gonna move a little bit more on the coding part. Okay, it's really how to implement machine learning. And all these things we talk about are really, really basic. Okay, so it's nothing really new. Any of the machine learning course you took in the beginning, they will talk about this linear regression, polynomial regression, classification, very basic stuff. But I really like this because it's the fundamental idea on how machine learning works. I wouldn't recommend you dive into the neural network first because it's a little bit harder to understand. It's very abstract, and also not to mention theoretically, we still cannot really explain very well why some neural network model works so well. But compared with the deep learning model, the traditional machine learning like regression, it's very clear. There are math behind it. Everyone can get it. It represents fundamental ideas. So I definitely want to master you those. And also on coding, I assigned some small assignments recently. I started putting a little more assignments. This time shouldn't be too difficult, but I do want to push you to get some hands-on exercises, okay? So very quick recap, okay? Because last week, on Tuesday, we talked about introduction to large model. We explained that basic what they do is just try to predict the next word, okay, next sequence based on the input. And I started to tell you the way it works is that they have a machine learning model, okay? They train a lot of attacks and they learn the text sequence so that you can have this function, the model, you give input, and then they predict the next word as output. So now I'm trying to let you understand how this thing works from the computer science point of view. How do we program this kind of model? It sounds very complicated, but it's it's manageable. Okay, so what do you need to do? I told you you have to provide this data set with input and output columns, and that way you throw that to a machine learning model to train it. Okay, but this is obviously very complicated. Let's actually start from very simple examples. And then we explain to you that brute force is not machine learning, although it's effective. Machine learning is a very good way, a strategy to deal with a very complicated problem that you cannot really solve very well using the traditional brute force algorithms. And then we start to give you this example, like a very quick recap on the example to predict the traffic. Okay, think about the step we did. Okay, first of all, we define the problem. Okay, we predict the traffic. This is the things we want to know beforehand. Okay, then we figure out what are the features that related with this target. Okay, we talk about the time of the day of the week, how's the weather, how's the accident, if there any kind of construction going on or any other big events going on. All of those will actually affect the traffic. Okay, so we start from the easiest one, which is the time. And then once we know that, the next thing you need to do is to feed some good data so that the machine can pick it up. So these are observations from 6 to 9, and we provided traffic levels. And then based on that, we start to do training, learning, and then we can do the prediction. Now, last week, we didn't dive into the programming. We just explained to you that if you were given this data set, and then you were trying to use a model to describe this. A lot of you can see this from mathematical point of view. Oh, wow, this is a very good linear function. And then you can use y equals mx plus b to represent this function. And if you believe this data fits within the function, all you need to do is figure out what's the best m and b that best fits all the points. And then that's where math is going to apply. Okay, whether it's like simple case, use 2 points, or some you mentioned about using the calculus to do more complicated stuff to figure out the best fitting line. Okay, so once you figure out that m and b, it's so powerful because that is a function, that is a model. We keep talking about a model. What is a model? So this is a model. Okay, because if you have this one, all you need to do is give me the input time, and I can calculate 10 o'clock, 11, 12, anytime you want. All right, but the challenge at the end is how do we get this M and B? Okay, because even like a little bit more complicated, we showed you that the data, if the data points are like this, it's not a straight line. Okay, you got a best fitting line, and I'm sure none of you can probably do that manually. Okay, unless you're a math major, you probably learned this before, but you probably haven't done it for a long time. And if you go with a more complicated situation, all right, so more data points, I want to get you the best fitting line, it's just going to get much more difficult. Okay, but fortunately, we're a computer science major. Okay, we don't need you to do math. We want you to use libraries to program this, to let computer to figure out MMB. Okay, so then let's take a look at how do we do this. So to dive into the programming, I mentioned the best library to do this kind of thing is something called sci-kit. Okay, this is a library written in Python, and it includes the most commonly used machine learning algorithms, mathematical functions that solve this problem for you automatically. All right, this is an open source project. As you can see, they have a lot of things going on with regression. There are all different kind of regression algorithms. We're going to use the linear regression, the simplest one. There's things like logistic regression, Bayesian regression, all the other things. But a lot of this, if you go back, look at the code and understand theory, it's mostly really with math and statistics. Okay, so if you eventually want to dive into machine learning research, AI research, I have to tell you that math in this case is important. Okay, it's not the most important thing, but without math background, it will be very hard to go deeper. Okay, so it's definitely something special about this field. All right. However, don't be intimidated. For coding, apply the model. You don't need a math. Okay, you just need to know high level how this model works. Okay, when I mentioned about linear regression, you know that's find the best fitting line. Okay, and the rest will be taken care of by the code. Okay, so let me just dive into the code to show you how this scikit-learn works. It's a library. Okay, so it's using Python. Now, I'm a big fan of using Rapid just because I use this one so many times. I know a lot of you do Google Colab. Some of you hold your own Jupyter. You use other IDE, VS Code. It doesn't matter too much. Okay, so I like this one just because it's so easy to set it up. You don't need to install anything. They actually help you to install the library. Okay, it works for most of the cases, but when the application get more complicated, Rapid probably either is not powerful enough or some of the library they cannot handle very well. So you probably still need to switch to other environment. So we'll see. But in the beginning, these examples are simple enough. I think you can just use Rapid very easily. So very simple. You sign up and then create a Python program. I'll call this traffic machine learning example. Okay, so and then create a Rapid. And then this is a broader based coding environment that you can start to code. Okay, so and they actually changed to the dark mode. Okay, I'm not, are you guys able to see that? Let me change the font size a little bit bigger. So where is the settings? Let's see. Okay, let me what is actually delight mode? Okay, I don't think that's related with UI. Oh yeah, seems. Let me change to light. I think it's easier to watch. And then the font size. Okay. Yeah, they changed this a lot. It was somewhere here before. Okay. Let's just start from here. Okay, I don't want to waste too much time to figure this out. But yeah, it's a very simple environment. You can just print and then run it. Okay, everything in the browser. Okay, if you do this and click on button run, it just shows result right here. Okay, so you don't have to install Python. And the code will be saved in the cloud. So I highly recommend you do this one. For the first assignment, just do this one because then you can simply share this link and then we'll open the link. We see the code, can run it. I think it's better than Google Colab is too heavy. Okay, so you don't need those for this kind of simple programs. All right, that's how Python works. Whether you done Python or not is not a big problem. Okay, so if you never wrote a Python program, take a online course, find a YouTube video. Okay, spend 1 hour, 2 hours, just learn the basics. That's enough. Okay, you don't have to learn too much about Python. It's very simple. All right, so let's solve this machine learning problem. Okay, this traffic prediction example. Okay, so there's few steps you need to do in coding. Okay, number one, you need to prepare for the data set. Okay, since you want the computer to learn and you need to get all the data ready, the table data I showed you, the time and traffic level ready. And then select a machine learning model or algorithm. After that, train the model, or we call it the learning. Once you train it, you're done. And then you can use the model to make predictions. Okay, basically these 4 steps. All right, so let's do this one by one. Number one, let's get the model ready. All right, so when you do that, you must be very clear on what your data features look like and what's the target you want to predict. When you prepare the data set, you have to split them because this is the data you want to predict. I like to call it output. And these are the data that features that's going to affect the output. Normally people call it features, input features, or let's put it very simple, we call it input. Okay, so you need to get all of this into Python. So I'm going to create one thing called input data. All right, since there are many data records, it's going to be a list. All right, so that's how you create a list. And then on the other end, you have output data, which is another list. All right, so that's basically what scikit-learn asks you to do to split the input and output. All right, so how do we do input? So in this case, they have just one feature, there are a total of 4 data entries I gave you. So 6, 7, 8, 9. Okay, so I'm going to put this one 6, 7. All right, 8 and 9. I'll just put it vertically so that's easier to map it, just like table. Okay, and the same case for output data, we had 2, 4, 6, 8. Let's do the simple case. All right, so 2, 4, 6, 8. Yeah, you can put them in the same line. That's fine. Okay, this just looks better so that you can visualize that the table. Now you might be wondering, so why do you add a bracket here and then you don't add a bracket here? Okay, the reason is very simple, because output data, you only predict one thing. So every row, you're just going to have only one target data to predict. But the input data, you could actually have multiple features. Okay, that's why we have the table multiple columns. But right now, we're only just using one, just using the time of the day. Okay, later on, you can try to add a day of the week, weather, all the information. That's when you need to add more data here to this bracket. So that's why you need to have a bracket inside. In other words, the input data is a list of lists. Okay, so every row is going to be another list. So you can put multiple columns inside. All right, so, or you can consider that a 2D array, same idea. Where this one is just one list. Every row represents the output for each of the data set entries. All right, very simple. Any questions? Okay, so that's a data set. Next, let's choose the machine learning model. Okay, now this is what the engineer to make the decisions. Okay, there are so many algorithms and there's so many different problems. Given the problem, now you as an engineer or data scientist need to decide which model I should use, which algorithm I should use. Different model handle different situations, have different features. But then we've been talking about, because we look at the data, we look at the graph, okay, and it looks like this data point follows straight line, has a very clear trend, very linear, incremental. So I'm going to decide to use a very simple way to represent data, which is linear regression. Okay, so I decide the model to be linear regression. Now in scikit-learn, well, you have to select the model and use that. Since that's going to be a very complicated process, that's where the scikit-learn comes into to help us. So in order to do that, well, you need to import it. Okay. Now this part you can basically start to Google. Okay, so sklearn, linear regression. I think you can probably find a lot of examples. This is a formal documentation, but I want you to focus on the code, and then you can from here see how you do the from import, how they use this one. All right, so that's one way. Another way I recommend is that, because these days, if you look at this kind of documentation, it's very random. The quality is different. Okay, like this one give you another one. This one show you a graph. But honestly, this is too much. Okay, in the beginning, if I give you so much code, you just feel very overwhelming. Okay, so another way always go to try is to use ChatGPT to help you. Okay, so please generate a very simple and concise code example to show how to use sklearn to train linear regression model. Okay, so I like you ChatGPT to give us a very, very concise examples. Normally it does a better job than some of the Google stuff. Okay, we'll see. All right. So this one will give you some examples, and then they give you the from, import, they prepare the data, and then they use some of the NumPy array to do that. I use a list, but then here they do the train, test, split. Here they do the model and the feed, predict something. Okay, so this is a good example, is good, but for the beginning, okay, it's still a little bit difficult for you to understand, because one, you don't know what this is, why do we need this? And secondly, you will be very confused on what the test, the training test split is. Okay, so anyway, but I just want to show you example. Later on, you will find the ChatGPT answers like this will be super helpful, because you already understand the basics. You can quickly get this example and use. Okay, but anyway, I don't want to show you exactly how you get those answers, but in the beginning, use both Google and ChatGPT, but don't underestimate. I think ChatGPT sometimes just give you more effective, more efficient answers. Okay, but here I just want to show you the step at the very first example that you have to learn, import the library, which is sklearn. Okay, inside this library, I want to import a class called linear model. Okay, that's the first thing to do. All right, and then with the linear model library, you can then create that linear regression. Okay, so I'm going to declare an object called model, linear model dot, we do linear regression. All right, so linear model is like a it's like a class, and then the linear regression, the specific algorithm that implement that function we talk about. All right, this part there's no, it's just basically importing libraries from Python. Okay, you just need to know it. You just need to know sklearn. That's a library that includes the class called linear regression. Okay, so that's where you can find from Google, from other references. Okay, so we decide this is the model we're going to use. All right, and now step 2 is finished. After that, this is the most important part. Okay, you select linear regression, which means that you are expecting to have a y equals mx plus b. Now the question is that, how do I know what is mx and b based on this input data? Well, that's the fun part. So we do model dot fit. All right, when you try to call fit, you're trying to get the best fitting line. Let the machine try to figure out the best fitting line, but you need to give the data. So you provide input data, output data. All right, that's it. And then let sklearn, let the computer to handle the complicated math. Okay, so let's run this. So I run this code. The nice thing about Rapid is they're gonna, based on your input, they will automatically go to import the libraries, pip install. That's a good part. I don't like the pip install part. Sometimes the environment is hard to configure. So the first time you run this, it's gonna take some time. They figure out the sklearn library and then some other dependencies like NumPy. All right, let me clean up the code a little bit while we're waiting. All right, looks like that's finished, and then it's running the code. Still running. Yeah, this is the virtual environment. Okay, so the CPU, I don't think it's very powerful, but it's good for you to use for example like this. Okay, now it's finished. Okay, it doesn't print anything because we did not ask them to print. Okay, but then you should know that after this line, they have already figured out the M and B. Okay, So let's later on show how do you know what is MMB, but if you have this model trained, okay, just like that thing I showed you here, you got this model, and if this model is ready, then you can start to give new input and they can predict output. All right, so what does that mean? So I can go back to code, I can start to make a prediction. So you do model dot predict. Okay, very self-explaining. And when you predict, well, you have to provide input data. And there's a data format you have to follow, because you see the input data, you give a list of a list. So which means here you have to do the same thing. So because I want to, for example, I want to predict that 10 o'clock. Okay, we already talked about 10 o'clock, there should be 10. Let's see if that's the case. So what I'm going to do is a list of lists. So that's going to be a 10. That's the number I want to, that's the time I want to predict the traffic. Okay. Once that one is finished, let me save that into a variable. I'm going to print it. Okay, very simple. Now let me run the code again. I run the code. And the result is that is 10 right here. Okay. So if I want to do more, and you can add more data point here. I want to do 11 o'clock, 12 o'clock, and I can even do, let's go back a little bit. I want to do 9:30. So 4 data points. So I'm going to run this code. All right, so 9:30 is 9, 10 o'clock is 10, and then 11 is 12, and 14. So basically incremental. All right, that's all it was. Okay, so this time you don't need to figure out that math. Last time you guys took you guys like a couple minutes to figure it out. Okay, now sklearn does that. All the magic happens here. Okay, this is the most powerful line of code. Okay, they do all the math, calculate, whatever they need to do. And if you're wondering, how do I see the M and B? Yeah, you can see that. Okay, so let's see here. So how to print the M and B in the linear, in the trained linear regression model. See, we told you this, very helpful. So you print a model dot coefficient, model dot intercept. Okay. So let's see that they give us examples after the training, and you print the slope and the intercept. Okay. So let's just try this. And then we do this one here, run over. All right, let's run this one more time. So this time, above the results, we should be able to see the parameters. Yeah, remember 2 minus 10. That's what you guys decided last on Tuesday, but they just calculated for you. All right. So hopefully through this example, you see the ideas behind machine learning. It sounds like a very advanced, very complicated. Wow, we talk about AI, we talk about all the large language model, but fundamentally, basically same process. Okay. From data, you decide a model, computers help you to figure out the parameters. And then you start to use that model. That's it. So never underestimate this example. Okay, you should really keep this in mind. Anytime in the future when people tell you about machine learning, you should be able to map everything back to this example. Exactly the same thing. The difference is that in some of the complicated scenarios, this data is huge. It's not going to be simple like this. It's not structured. You have to clean it up. Okay. And then this part is way more difficult, complicated, and more complicated than you can ever imagine or understand. They use neural network, they use all these different names you never heard about. Okay, so that's the only difference, but the steps are the same. Okay, define a problem, give the data, select model, train the model, and then use the model. Okay, see, this program is 1, 2, 3, 4, 5, 6. It's just a 6 line of code. You do a machine learning problem. Okay, that's why we do Python, because really you can only do this so simple, so efficient with Python. You basically cannot really do this in Java or C++. Java, I know there's a library called uh, there's something called a welcome. Okay, so you can also do this kind of thing, but it's not easy to use. Okay, so that's why Python is so popular. Very concise. All right. Any questions about this code? All right, so let's start to change this a little bit. Okay, I mentioned that this one is easy because you guys can figure out this 2 and minus 10 very quickly. Okay, let's switch a little bit. Like 7 o'clock is 5, and 8 o'clock it's 7, and 9 o'clock maybe 8.5. So it's not a straight line. Okay, it's just like the one I mentioned here. Okay, it's a up and downs, but you know the trend is still there. In this case, we need to find out the best fitting line. Okay, that's just more difficult. This one you have to do with the calculus. All right, again, we don't know how to do it, but it's not a big deal. So we run this again. The input data has been changed, and you see the results. This is really slow for some reason. It's a very simple program. Yeah, normally it's not this slow. Okay. Yeah, but anyway, see, slope is 2.15, best fitting line, and the intercept 10 negative 10.5, almost similar to the one before, but it's much more accurate. Now see the results, like 9:30, you got almost 10, and then it's 11, 13, and 15. Okay, based on that points. Okay, so super accurate. All right, so that is how machine learning model in practice using Python and scikit. All right. So very simple. Okay, so let's actually start to get a little bit more complicated. So the next thing we are trying to try is this. Okay, so we go back to this problem. Okay, now this obviously is a very simplified situation for traffic. The actual traffic is more difficult, more complicated than this one, because as you all know, we're talking about a 10 o'clock. 10 o'clock is definitely not going to be the peak, right? It should be around 8 or 9, maybe after 9, 9:30, since at least it started to slow down a little bit. Okay, so the reality probably is that 10 maybe somewhere here, right? And 11, it will be really light. Probably 11 will be here. And 12 also not very good, not very bad. Okay, that's how the traffic works here in most of the places. But if you see the model here, we do 11, 12, that gives you 13 and 15, that should go even higher. And that's not the reality. Okay. So if you see this prediction isn't very good, then what's the problem? How can we fix it? In this case, just based on this case I gave you, why, based on all the work we do, you know, we do 9, 13, it looks good, 10 is okay, but why 11, 12 becomes so bad? Right? Which part, you know, caused this problem? Uh-huh, uh-huh. Yeah, but you know, that's another problem. Let's assume that we don't specify the upper limit. Okay. But from the data, it shows that at least they tell you 12 o'clock, the traffic is much more worse than 9:30 and 10, which is not the case. Yeah. We use the linear model, okay. But we use the linear model, and there's a simple why, because if you see the data points, it looks like a linear model, right? That's why you decide to use a linear model. Exactly. Okay. Because this one, you guys can imagine, you're driving, you know the situation. You don't feel this is that hard. But think about that. I give you a brand new domain. I give you a medical data. You have no experience, no idea. Okay. You can't make any kind of assumptions. All you have is data. You must learn based on what being provided. If I only gave you this data, well, you choose the linear regression. That is the right choice. Okay, there's nothing wrong with that select decision because that's exactly what data showed you. Okay, you don't want to mix. Sometimes you can mix your personal experience, but the most important is to look at the data. So the fundamental problem is that we actually didn't tell you what the situation looks like when you go to the node. So you cannot expect the machine be able to learn that by itself. There's no way. Okay, so whenever you see a bad machine learning model or training, first thing you should think about to improve is, do I have enough data? Okay, if the data is not there, I mean, no matter what the computer you use, what model you use, it's not going to be very good. Okay, that's why ChatGPT is heavily rely on the text data. If you look at GPT 1, 2, 3, and 4, you look at the amount of data, it increases dramatically. Okay, so because that's gives the power. That's why every single company right now pay so much attention to data. Data is almost like a guess. Okay, without data, the machine cannot really figure out the patterns. Okay, so in order to help you with that, okay, I start to do more observations. So I found out at 10 o'clock, well, the traffic actually is a little bit better. And then 11, it's actually really good, maybe 4.5. And 12. Okay, it's really easy. Laser is a real observation measurement I saw. And now I gave it the data. That's a lot better. Let's try this. Okay, so I'm going to put this data back to my code. So I need to provide a little bit more. I have 10 o'clock data, 11, 12. I got 3 more. So it's a 7, 4.5, and 3. So 7, 4.5, and 3. All right, so we got some new data points. Okay, let's make some predictions. I don't want to predict the ones we already saw. So 9:30, I want to know it. Maybe I do 10:30, 11:30. I'll do what? Maybe 2 o'clock. Okay, I want to see the points I haven't seen before. So based on that, let's actually run this again. See what the result is. All right, so it tells me 9:30 is 5. 10:30 is 5, 11:30 is 5, 12 is 5.6. Almost the same, slightly improved. Okay. Then you go back to check, is this result good? Right. So for 9:30, that's not good because 9:30 actually is very high. You gave me a 5. It's even below here. And then 10:30, you also show me 5 point something, but looks like here, it started to drop, but not bad, right? So it started to drop, that's okay. But then you see 11 and then the 2 p.m., you still keep it 5, then that's actually not good because at that point, it's already very, very low. It should be even lower. Okay. So now, can anyone explain to me what's wrong with it? Why the result is still not good since we have the data? Yes. No longer linear, very good. Because we told machine learning to do linear regression. Okay. Now you gave me more data. Okay. 10 o'clock is here. 11 is here. And 12 is here. But I didn't change the model. I still think this is a linear regression. Obviously, this is not anymore. But since you told sklearn to do linear regression, well, they will still need to do a best fitting line, right? So what the best fitting line will look like? Yeah, it's almost straight, right? So this is the best fitting line in this case. It's probably something like this. Best fit. That's the best they can do. See, that's why now you ask me 9:30, 10:30, 11:30, 12. It's just basic here along this line. Okay, that's why they're almost like 5 to 6 and didn't change so much. That's the reason. Okay. Now you realize that, well, our model is not good. Okay, because this one, you want this model to capture this trend, the errors in the margin too much. Now let's improve the models. Okay, but don't always go there to change the algorithm. It's not always about the algorithm. First of all, look at the data. And based on data, you select the best model that handles this kind of situation. Okay, Now, to move a little bit further, we don't want to do the linear regression because that's not going to work. So what other model we can use in this case? Polynomial, okay? So it's basically, we want a more like a curved model that can capture this kind of a trend, right? So, you guys already learned this in math. How do you, let me see if I can draw one. You need something like this. Yeah, something like this. So how do you specify this model in math? What is this? Yeah. You don't remember that? Do you remember this one? Yeah, so that's it, right? So that's the model to describe this one. We call it polynomial regression, whatever term we call it, but that's the math behind it, okay? If you tell me A, B, and C, I can draw this line and it's going to be fixed. And then if you have that A, B, and C, then just give me a new X, I can predict it. But the question is that, how do I do the best fitting curve like this? And what is A, B, C? There, just forget about it. It's too hard. Okay, we don't know how to do that. So sklearn do that. Okay, now in this case, you have to start to switch the model. Okay, we cannot use a linear model anymore. We need to use polynomial regression. Okay, so again, just to show me the simplest version of polynomial regression using sklearn. This one do require a little bit more import. That's why I can't remember, but a lot of this one just always try to Google and try to find the thing that works. Okay, so they apply, they still have a linear model, they use linear regression, but then they also use this thing called polynomial features. And then when they specify the model, they do something like this, they do a features and they do a transform, the data and the linear model, fit. I don't know if this is the one I'm looking for. Okay, let me make sure that this is a poly and then you need to in the fit transform them. Okay, and then you apply this model. Okay, it seemed to be all right. But there is another version I know we're looking for. Okay, I want to differentiate that from the linear regression. So let me just check. Okay, just double check. sklearn, polynomial. All this version works, but I'm trying to figure out a better example for you to use to understand. I don't want to bring too much extra stuff for you. I want to get a simplest one. Okay. From the code. So that's data degree. So that we still need it to define a degree. The features. Okay, you create the features. This one, they do the same thing. And okay, so eventually they still use a linear model to do this. Okay, yeah, this one should be fun. Okay, so let me just see if, just in case anything else. All right, looks like they all do the same thing. Okay, features, and then use that feature to transform the input data, and then use the linear regression model to create a model. When you fit it, you actually use the transform data to do the fitting. Okay, so it looks like it's really just the fitting part. They change the data point somehow. Okay, so let's just stay with that. All right, so go back here. So let's try to import it. So that one, we already have it. And then we also need to import the processing. Okay, I'm gonna get this line here into my code. All right, and then the difference is that I'm gonna keep this model here the same way, but I'm gonna create a different one. So we are gonna do polynomial features. That degrees means it's a square. Okay, degree 2 means square. You can also do cubes. And then we do transform. Okay, so you're gonna transform your input data. Okay, this is the most important difference. They can probably somehow manipulate and manage the data stuff differently. And then we're gonna create another model. I would call it a model 2. They still use linear regression. But this part is actually the same thing. All right. And then, but the difference when you fit, you actually provide the model being transformed. Okay. So going back here, when you're training, model 2 dot fit, you don't do input data, you do X poly. Or maybe I would change the name. Okay. Input data poly. So that way you know it's in polynomial data. And then output data. This one remains the same. All right. That's how you do the second model using polynomial regression. Just a little bit more work. And then you might be wondering, so why do you do this? How do I know to do this? The answer is you don't need to know how to do this. You look at the references. Okay. That's what sklearn asks you to do this. You just do it. Okay. As long as you know what this means, what's the purpose, we just take it. That's the expectation. Okay. Unless you're doing the research, you want to improve the polynomial regression algorithm parameter, then you dig into inside. Okay. But these are the library code, framework code they provided. We'll just follow it. Okay. All right. So we have two models, two learning process. Let me try to. This is linear regression. Okay. This is polynomial regression. Okay. Two models to choose and then two training. And I'm gonna skip this one, okay? I'll not print this. Okay, actually, let me comment it out so that as a reference. And finally, you predict things with this one, and also you can predict that with another model, second model. All right. Now let's take a look at the difference. Okay, same data set, two different models, and then two sets of results. All right, something's wrong. As one feature, but linear regression expecting 3 features. What's wrong with it? Let me see. So they're talking about it here. Oh, I think for the prediction, we also need to, yeah, we also need to transform it. Actually, not sure this is the best example because I remember you don't have to do that. Yeah, when you predict, you still need to transform that. That's very tedious. Okay, I gotta find a better one next time. Okay. Anyway, so the problem is that you see that when you're training, you have to do this thing to transform the data, but here you have to do the same thing. That's actually not good. Okay, a little bit tedious. Okay, but I'll try to change a different one next time. Okay. Anyway, so here now two different sets of results. Okay, let's compare. The first one we already saw it. 5, 5, 5, 5 is basically just like this best fitting line here. Okay, and the second one, so 930, it says 7.5. Okay, somewhere here. Very good. Okay, it started to drop. It's yeah, because 10 is not the highest, so they started coming back a little bit. So that's actually very accurate. And then 1030, it's 6.6, and keep dropping. And then 1130 is already like 4 traffic. So going back, and then 2 o'clock, it can actually get into -7. Okay, whether it's reasonable or not, but you know it's below, way lower than the previous hours. And the curve's going down. Okay, see, that second result is so much better than the first one. Okay. The reason is because you choose a better model and the best fitting gets more accurate. So from this example, you can also tell the model also matters. All right. I'm trying to keep letting you know that when you work on a machine learning model, really you need to get good data, good model. Okay. Another one we didn't mention, but you should also be able to see that's going to affect your result is the features. Okay. Because right now we only showed you like right now it's 11 o'clock. Right now, if you go to the traffic, okay, I guess it should be very bad. The traffic. Yeah. So, 11 o'clock, I mean, not too bad. Yeah, but we want to know because the weather is bad. Okay. So it's not just about time. All right. So if you want to improve more, well, you gotta look a little more about what the model features are going to affect you, right? So instead of just look at the day of time, can we also look at the day of week? For example, if this is a Monday, that all makes sense. But what if this is Saturday? Okay. I don't think it's going to be the case. You're not going to get up at 6 or 7 on Saturday, right? So if it's a Saturday, I would say this is 1, this is 2, this is probably 3, and this is probably 4. Okay. But around noon time, I think that's where you pick up the traffic because now people start to go out to relax and play different things. So maybe 10, 7, 11 is 8, and 12 probably 9. Probably. Okay. Saturday, you're going to see total differences. That's how you can capture the problem even better. And then later on, you can add weather. Okay, if it's a good weather, the same thing. But if the weather is really, really special, then every time is bad. Okay. So the features also matter. But let me show you how you can add this one to the program, and you probably can figure it out. So all we need to do is go here, because I told you the input data can have multiple entries. So this is a Monday. All right. And then all you need to do is let's add the Saturday. And then this is the Monday's records. And then this is Saturday. I'll just randomly put something. Okay, 1, 2, 3, maybe 3.5, and then 7, 8, and 9. Okay, just create a different kind of a trap. So if you want to predict Monday, well, now everything here should be changed. There's a Monday data. Here's also Monday. All right, now run it. The result should be similar, okay? But it's not gonna be the same, but it's still similar. See, this one 5, 6, 7, 9, and the other one is 6, 5, 4, and 0. Okay, so that's Monday data. But if you try to do, because we know the second model is better, okay? So we're gonna try the Saturday data. And hopefully that gave us different results. Yeah, see the Saturday data. So if it's it's a Monday data, so 6, 5, 4, 0. But Saturday data, 6, 7, 7 higher, and then 6. See, in the Monday at 2 o'clock, it had to drop so much to 0. But the Saturday, it didn't drop that much. It's almost the same as at 12 o'clock. That's what we want to see. Because in the afternoon, on the weekend, it's going to be very busy. All right. So based on this example, guys, really I want to show you solving a machine learning problem. All right. Basically like this. Not that difficult. Okay. From now on, you should know, yeah, this is okay. But it involves a lot of experiences. Okay. First of all, you have to understand that problem very well. You need to know what you're trying to predict and what are the things that are going to affect this. Okay. You must understand that. Okay. Otherwise, you don't know what to analyze. For example, I want you to write a machine learning program to play Go or chess. Very difficult. Okay. You never even play it. You don't know what to model, what to capture. You don't know what's important. But if I ask you to do tic-tac-toe, you know it. You know the position matters. You know the edges matters, corners matters, right? The center matters. So knowledge, you need to have that. Okay. Figure out the best way to describe the problem, figure out all the relevant features. Okay. Enough features. But at the same time, you cannot go too many features. Something called overfitting. And if you take a machine learning course, you will learn that. It's not like you give too many details. That's going to make the machine learning problem too complicated. And because some of the features, like the traffic, the time is the most important. And like invents those, maybe not. Okay. So you never know. So it's not about the more the better, but you need to capture the most important ones. Okay. Once you decide that, all right, then it's basically the samples. We already showed you. If I didn't tell you, the trend will come back. You never know that. You have to show that from the data. Otherwise, machine also don't know that. Data is so important. Based on the data, based on the problem, then using your data science, machine learning knowledge, decide which model to use will be the best. There are so many models available to deal with different things. Researchers are designing new models, new algorithms to make an improvement. Okay, so if you go to grad school to do a PhD, if you do machine learning research, more than likely you're going to design your new algorithms. Okay, then run experiment to tell people why your algorithm is better. But at this point, you don't need to do that. Okay, focus on applying the models. But to apply the good model, at least you need to understand how it works. You need to know, okay, linear model is actually like this, polynomial is like this. And there are more things like a logistic regression. And then later on, we'll talk about the classification. There's so many, okay. But you don't, it's complicated, but you don't need to know all the details about the math. But you do need to know when do we apply this kind of models? What are the typical cases that use the models? And you look at an example of the reference. Oh, actually, Amazon recommendation model, they use logistic regression. And maybe I'm going to build an engine to recommend games for my users. I can probably apply the same thing. So you look references and figure out what's the best model for you to try. And then just train it and try to see if it works or not. Run some experiments. And then you decide what is the most optimized way to describe and implement this model. Okay, so that is machine learning, guys. Okay, so you do not need a whole course to understand this one. If you understand this traffic example very well, I kind of covered all the most important things, but I really want to show you the code is actually really, really simple. Okay, much simpler than you ever saw. Okay, it's good. Like I talk about this one because I don't have too much about a math and machine learning background, but I know the practical part. Okay, so otherwise, if I give you too much fit formulas, everything, I thought that would be very helpful. Okay, so these steps, that's machine learning. Any questions? Yes.
When deciding the model, would you plot it or just do like trial and error to see which model fits?
Both. That's why you see a lot of this example they actually gave you, to plot it, right? But you think about the plot is very limited. You only plot 2D or 3D. What if I give you, what if this, like you have 4-dimension? The 4-dimension, you can still plot it, right? Like if you use all the 4 features, you can probably still draw multiple 3D like graphs. But if I give you 10 features, you cannot plot. Okay, so you cannot visualize it. Yeah, but experiments, that's always you need. It's called a validation. Okay, verification. So there are different ways to verify this. We can cover this one a little bit more in the future. Yeah, but most of the time you do AI research, machine learning research, you're trying to figure out what is the best model, what is the best parameter, what is the best data set feature you choose. and you run tons of experiments. That's why you read the AI paper, machine learning paper, they have so many graphs to show you this is more accurate, this is more stable, this is less errors, and that's the research about. Okay. But whether you choose the best model or not, that has required a lot of experiences. Okay. Yeah, it's a very fun area. Okay, if you're very interested into like data stuff, math stuff, this is a very good area to get into. At the same time, sometimes a little bit tedious. Okay, it's not easy. Okay, the traffic is a very easy example, but in reality, you can probably assume that there are so many complicated problems that's not as straightforward as this one. Okay, but this is the fundamental, because if you know this, you can then try to figure out how do you predict the sequence of attacks. But that part is not as straightforward as this one, because you need to format the text and strings and token stuff. But we can show some examples probably next time. Okay, so that's the main thing I want to cover today. With that, I really want you to get hands-on stuff. You can't just watch me to do this. Okay, I know this. Even though the code is so simple, if you don't type it, it's not going to work at all. So this time, I'm going to change my style a little bit. Normally, I don't do too much assignment. Okay, this course, I definitely let you do more. Okay, but all the small ones. This one is very simple. Now, you pick the problem you want to predict. I don't require it. Okay, so I pick the traffic, but you do something meaningful. Okay, useful. You decide it. But no matter what you do, okay, you have to figure out that table, what that table looks like. All right, what's the target? Draw the table. Okay, every machine learning model, you should be able to put a table like this. Okay, this is very important because that helps you to understand the problem domain, help you to understand what kind of data you need. Same thing. That's why for this one also eventually you will have tables. Okay, what's the target column and what's the input features? Okay, so you pick your problem and then you provide the data. I don't require that. You put dummy data, that's fine. You put, your experience data like I do, 6, 7, 8, 9, that's fine. Or you find some data set that's even better. Okay, you can always Google certain data set online somewhere, but normally the data set will give you like a CSV file. You need to know how to use the Python to read those data. That's not too hard. Okay, if you use the data, that's even better. Okay, if not, just do some sample data, and then create a model to use that, to do that. Then at this point, I only need you to do linear regression and polynomial regression. Okay, if you want to explore other models, of course, totally fine. Okay, but at least you need to show two models, how to train this, and then the result. You don't need to do formal evaluation, but you should be able to train stuff, predict stuff, to just test out how the model works. Okay, just submit a replicate link. I don't need documentation or anything. Just put me a link. We can open the link. I can click on a button to run it. I probably won't run it. Just look at the code to see how to do it. Okay, put some comments to explain what the problem you're trying to solve. Okay, so finish that by within a week. Okay, so you got a hands-on. Okay, very important. Don't just listen and took courses. Just write a code. All right, so that's all we want.